Hey guys, so we are going to watch this really short video really quick. I'm not going to play necessarily all of it, but it explains what a parabola is really well. This is from a group of people called Don't Memorize. They make some really good videos that actually explain how things work, not just like the formula. So,
do you know what's the shape of a dish satellite called? That's right. A dish satellite is parabolic in shape. We've seen this in one of our previous videos. It's made up of this type of a curve. We can find many such examples of parabolic surfaces in our daily lives. One of them is the mirror used in a flashlight. It's also made up of this type of a curve. Let's consider just one of all these curves. Such a curve is called parabola. In this video, we will understand what exactly a parabola is. We can see that a parabola looks like a U-shaped curve. But every U-shaped curve is not a parabola. A parabolic curve has a specific property that makes it a parabola. Let's begin with understanding why the dish satellite or the mirror in the torch is parabolic in shape. In the case of the dish satellite, due to the parabolic shape, all the incoming signals falling on the dish are reflected towards a single point. This is where the receiver is placed. So the parabolic shape helps in concentrating all the incoming signals at a single point. Such a point for parabola is called its focus. And every parabola has a focus point. And this is what makes a parabola so useful. For example, in the case of a torch, a bulb is placed at the focus of the parabolic mirror. We know the light emitted by the bulb spreads in all directions. But due to the parabolic mirror, the light emitted in this direction is reflected in the forward direction like this. So we see that a parabola is a U-shaped curve related to which there is a special point called its focus. A focus point of a parabola is similar to the center point of a circle. And so, as in the case of a circle, a parabola is actually defined using its focus point. Let us see how. Let's take a point on a plane and name it as point F. Also, let's take a straight line and name it L. Now, please listen carefully to what I'm going to say next. We will now consider points which are at an equal distance from point F and the line L. Are there any such points on this plane? Yes, consider this point P1. It will be at an equal distance from the point F and the line L. Consider another such point P2. Its distance from point F will also be equal to its distance from the line L. Another obvious point is the midpoint of the perpendicular segment connecting point F to the line L. All such points that satisfy this condition will lie on this curve. And such a curve is called a parabola. So how can we define a parabola? We see that a parabola is the set of all points in a plane that are equidistant from a fixed point F and a fixed line L. It's called the focus of the parabola, and line L is called its directrix.
okay, so I know that was a little bit much probably, but basically we're going to draw this as a dashed line. We're going to put our vertex, which is this one right here, on there. And then the focus is going to be this point in the middle. It's not super important for graphing the parabola, except for you could always measure the distance from here to the line, and it should match from the line to the directrix. I'm going to go ahead and flip over to my paper set of notes, which is what I had ready for you guys to print off if you needed it. So here we go. And I'm going to kind of explain the most important parts of it. I did not label all of them on these. I labeled the most important parts because I didn't want to overwhelm you too much with the pictures. Don't worry about these things that I wrote through. I fixed them for your copy if you are looking at this from the one I gave you or the one I posted on Classroom for you. So the vertex is the turning point of the curve. That's the one right here or right here, up here or down here. So it's sort of like the middle. I know that she said that the focus is kind of like the center. We're going to say that the vertex is almost like the center here. She was just referring to it as the fact that the points are equidistant. The focus is the point inside the curve that is p units away from the vertex. And p is part of the equation. I'll talk to you about that in just a second. So from the vertex to the focus, this is the focus right here. If you want to label it, you can. And it is p units away, so you see we've added p here. And the directrix is p units the other way. So it is a dashed line perpendicular to the axis of symmetry. The axis of symmetry is an imaginary horizontal, in this case, line going like this. So it's perpendicular. I usually just say it's kind of parallel to the vertex over here. And it is also p units away, but I'm calling that negative p because it's heading away from the parabola. Okay, the parabola heads this direction and it sort of encompasses the focus, and then the directrix is over here just kind of off to the side. It's almost like this directrix is repelling the parabola. This is not an asymptote. I don't want you to get that confused with the ones we've done before because this one is going away, not towards. And then the axis of symmetry is lying through the vertex and the focus. So that's how I drew that right there. I would not recommend drawing that on every single parabola. It tends to look a little confusing if you do. So let's talk about the equations for a second. Number one difference between the conic sections we've talked about and this one is only one variable is squared. So over here y is squared and over here x is squared. If it's x equals, the x values are the ones changing. So it's going to go horizontal either to the left or to the right. These are two separate graphs, guys. So a parabola only has one of these U-shaped graphs, whereas a hyperbola had two. It's going to open to the left if p is negative, and to the right if p is positive. If y is in front and it's the only thing not squared by itself, it's either going to go up if it's positive, down if it's negative. And then I've pointed to the vertex for you. That's this point in the middle. This line right here is the directrix. But notice how sometimes it goes side to side and sometimes it goes up and down. I'll explain kind of the best way to approach that as you graph it when we do our examples down here. P is the length from the vertex to the focus, and negative P is the length from the vertex to the directrix. They're both basically P, but they go in opposite directions. 2P is the distance from the focus to 2 points on the parabola. So if you notice, I put some points here. This is the focus, and if you go up 2P or down 2P, there's 2 points on the line. This just helps us draw the curve because the vertex alone doesn't tell us how wide to make the curve. Right? And then we are going to have to write the equation of the directrix. If it is a horizontal line, it will be y equals. If it is a vertical line, it will be x equals. And there's actually kind of a little trick you can use for that, and I will show it to you in just a second when we get to our first one. So first things first, since this equation doesn't have y by itself, we have to divide by -8. And what that means is that this is just going to become y all by itself. And then I'm going to actually write this as 1 over -8 x squared. Because that x squared technically already had a 1 in front. And there's no parentheses on this one because our vertex is at 0, 0. So right here in the middle. And then here's where the tricky part comes in. This is actually equal to 1/4 p. That's what's in front of the parentheses. So 1/4 p equals -1/8. And we have to figure out how to get p by itself. After we talk about it this first time, you can use it as a pattern. If I want to get rid of that 1/4, I multiply by the reciprocal, which is 4. So then it's p equals, And instead of writing -4/8, I'm just going to write -1/2. Okay, P is negative and Y is by itself. So I'm going to come up here, Y is by itself and P is negative, so it's going to open down. Always decide that before you do anything else. In fact, I'm going to write down underneath. So I'm going to go down 1/2, and that's where my focus is. I know it's hard to see on these graphs because they're small. And then if I go up 1/2, that's where my directrix is. Okay, so my focus is right here, over 0, down 1/2. So 0, -1/2. My directrix is up 1/2. Since it is a horizontal line, it should be y equals that 1/2 that we went up. Here's an easier way of doing it. If this is y equals, this will be y equals, and the y value is the value changing in the point. Then, from my focus, I'm going to move left and right 2p, because I said that that was the distance from the focus to 2 points on the parabola. So 2 times 1/2, or -1/2, is 1. So from here, I'm going to go over 1 this way and over 1 this way. Now you might be asking, why are you going left and right? Because I'm going the opposite direction of the vertex. So I have to go left and right because otherwise I'm getting into all of this stuff right here. So it should always be perpendicular to the axis of symmetry, which is right through here. Or some people say that it's always parallel to the directrix. That works too. Now, the shape on this one is pretty skinny, and some people are like, that doesn't look like what she showed in the video though. The smaller the value that P is, the skinnier the parabola is going to be. Okay. Now let's talk about the next one. I'm going to divide by 6 on both sides so that x is all by itself, and it's going to equal 1/6 y squared. There are no parentheses on this one. There's no extra numbers there, so my vertex is 0, 0 again. And this time, 1/4 p equals 1/6. I'm still going to multiply by 4 to get p by itself. 4 out of 6, which is the same thing as 2/3. Oops. That's why you don't talk and write at the same time, guys. So that means that it's positive, and x is the one that's not squared by itself. So that plus the p is positive means we're going to open up to the right. Again, go back to your table and decide that before you draw anything else. So that means we're going to go to the right 2/3, and that's our focus, and to the left 2/3 is our directrix. That's the one where we actually need to draw a dashed line. So my focus is 2/3, 0. I can also calculate that myself by adding this number to the x value. The y value stayed the same. The directrix goes to the left 2/3, so that's at -2/3, and it's x equals because it's a vertical line, and vertical lines are x equals. Or use my little trick, if this is x equals, this will be x equals. And then we can draw our 2 extra points using 2p. 2p is 2 times 2/3, so that means they're going to be 4/3 away. Because 2 times 2/3 is 4/3. So I can go up 4/3, which is about 1 1/3, and down 4/3, which is about 1 1/3. Like that. You do not need to write the coordinates of those points. This is just the distance from here to here, or from here to here, the same way that I showed you right here. Okay. All right, now let's do some that have a little bit less fractions so you can see them a little bit better. I kind of tried to start off with the harder ones in the beginning. So with your vertex, be careful because the vertex on this one looks like it's going to be 2, 3, but it's actually not. So the part on the outside never changes signs, but notice how when we switch from horizontal to vertical, or vertical to horizontal, the K and H values kind of flip-flop, okay? So the vertex is still these 2 points, but the one on the inside is actually going with the Y value, and the one on the outside actually goes with the X. Now, one thing that's a little tricky about this is only the one from the parentheses needs to switch signs. So this one needs to become positive 2, this one stays as a 3. Okay, this one goes with the X, that's why it's going first. This one goes with the Y, that's why it's going second. That's how I did the order there. So that would be right 3 up 2. Okay. And then my number out front this time is a -1. So I didn't have parentheses on these, but I'm basically looking for the number that goes in front of the y squared part. So this time 1 over 4p equals -1. So when I go to multiply by that 4, so that they cancel out, I get p equals -4. Now, I have a negative p, and x is the one in front. So that means negative p with an x out front is opening to the left. So I'm going to go from my vertex -4, which means left 4. That is my focus. And I know that I'm moving along the x-axis because x is the one by itself. And then I can go 4 the other way, and that is my directrix. So when I go the opposite direction, that's where I draw my directrix. And then that means my focus is -1, 2, because again, I'm changing the x values by 4. So I'm subtracting 4, but the y value is staying the same. And for the directrix, it's going to be x equals, just like the equation, but now x is all the way over here at 7. 3 plus 4 is 7. 3 minus 4 is -1. You basically add this number to the x value to get this one, and subtract this number from the x value to get this one. And then we need 2 extra points, right? The 2p part. So 2p is going to be 2 times 4. Sorry, -4 technically. So whatever p is, you double it. That's 8 or -8. Doesn't really matter because we're going to do both. We're going to go up 8. 1, 2, 3, 4, 5, 6, 7, 8. And down 8. 1, 2, 3, 4, 5, 6, 7, 8. And my parabola goes through those 3 points. Like that. And we have one last example over here. There is a 1/2 in front. So 1 over 4p equals 1/2. Still going to multiply by 4 because I still want p by itself. If you haven't noticed, on every problem we've multiplied by 4. 1/2 times 4 is 2. My vertex, make sure you put x then y. The x part is going to be -1 because the part in parentheses always has to flip when it comes out. I just had to flip the y one over here because it was the one in parentheses. And then the last number is my y part. It doesn't need to flip because it's not in parentheses. So -1, -2 is my vertex. And for my focus, I have to go decide y is by itself and p is +2. So that means y is by itself, p is +2. So it's going to open up. So I'm going to go 2 up, and that's my focus. And if I go 2 down, that's my directrix. So my focus is -1, 0, because -2 plus 2 is 0. And my directrix is y equals, because it's a horizontal line, and it was y equals here, so it'll be y equals here. -2 minus 2 is -4. Or I can count on my graph, 1, 2, 3, 4. Then we need those 2 extra points so we can actually draw our parabola. If p is 2, then 2p is 4. So I'm going to go 4 this way and 4 this way. Okay, you're always kind of following the direction of the directrix to do the 2 extra points. Like that.